Welcome back, everyone, to another Up to the Time presentation. Today, we'll be looking at Helix. So first thing, let us go and define what a helix is. Helix construction. An object having a three-dimensional shape like that of a wire wound uniformly in a single layer around a cylinder or cone, as in a corkscrew or spiral staircase. In geometry, this is a curve on a conical or cylindrical surface that would become a straight line if the surface were unrolled into a plane. What is the pitch of a helix? The pitch of a spring is a distance from the center of one coil to the center of the adjacent coil, like threads led on a bolt or screw. Pitch is sometimes confused with gap or the space between the coils. So it is recommended that the engineer specify the number of active coils when designing springs. So this is a finished look of an exercise. This is what we are going to be attempting today. Now, before we get into that, let me just show you. Let's have a look here. So this is a helix, and I'm going to put my annotation out now. And let's see what we have here. The whole thing is the helix spring path. So the path here, as this travels, is the helix, all right? All the way, starting from here and going all the way to the top here. That is the helix path. What is the pitch? The pitch is this distance here. That was explained. That is the pitch there. And the radius of the circle, if you were to imagine a circle there, it would be 10 millimeter radius. So let's have a look at another one. This is the same thing here. Only thing, it is directly vertical. So again, we can see the pitch and we can see the full height. All right. That's the full height there. All right. Now, some people get mistaken between a helix and a spiral. All right. A helix travels in this direction, vertical, and the spiral is on a flat surface. Right, so you're here and you're on this flat surface and you end it here in the middle, but you're still on the flat surface here, right? Whereas the helix, you rise. Yeah, you keep rising, or if you're at the top, you descend. You go down. If you're at the bottom, you go up, right? Whereas this is on a flat piece of land. So we can put here flat. All right. You see what else? Now that this is what a spring would look like. I think everyone's familiar with the spring. And this is what you can use a helix to design. So you would take the path of the helix and you use that to generate the spring. You would add a thickness onto the path, and then from there, you would be able to generate your spring. So springs can either have a circular thickness cross section, or it can have a square cross section. All right. Now, in looking at this topic, I realized that when we compare the pitch on this diagram, well, this diagram here has lots of strong parallels relating to music. Anyone that's musically inclined would know that these are musical notes here. But look at this. What this note here is telling us, that this here is the pitch. And you can see the pitch here is the distance from here, again, to here, right? That's the pitch. I wouldn't get too much into this, but I'm just showing you that there are strong parallels here between music and geometry. Now let's look at the question. What does this question ask? Figure 6 shows the plan and elevation of a cylinder with a point on it. Draw the given views. Construct a right-hand helix on the circumference of the cylinder starting at point P. Show hidden lines. Okay. So let's highlight what is necessary. So we need to draw the given views. So it's this view we need to draw and that. But in this present moment, these views are incomplete. So we need to complete this by showing what happens here, where this goes in this direction, and it meets its way back up there, or something of that sort. And to complete this, we need to divide this into 12 pieces, right? So we have our 12 pieces, like the clock face there, etc., etc. Now, let us go and have a look at the model. I've done a model. So I think this is going to help us. So here we can see that this is a path. This is a path here, and the path starts down here and it ends up here, right? But what is the pitch of this path if someone wanted to reconstruct this? The path here, the pitch here is 6. So again, in layman's terms, how would I explain this? We start here, and in order for you to make one complete revolution would be right here, right? Let me use a different color so that you guys can see. So you start here. This is where you start. And if you wanted to make one rotation, I should say, one rotation will end you back up here, and that would be our pitch, right? One complete rotation would right here will end right back up here, and they always line back up directly above each other, right? So that is how we can define the pitch there. Now let us move over to another illustration. This is what we're going to be dealing with today. This is what we're going to be drawing. Let me turn on the perspective so that we can have a better look at it. Now, this is the complete answer here. This circle is a circle of radius 35 mil, which makes it a diameter 70. And the distance up is 75, right? That's the distance up there. Now, one thing we'll notice about this is that we start at this point right here. Again, we start here and we end back up here. You realize that the distance is much larger than this distance. That's what determines the pitch, this distance. So from here to here is the pitch, and whereas from there to there is the pitch. I had to make this very clear because a lot of people get confused as to what the pitch is. Some people assume that this would be the pitch there. No. That's the distance of the full cylinder. We only want the pitch. Once we get the pitch, then we can multiply the pitch, the distance of the full cylinder, so that we can get the full thread, the full grooves that go onto the cylinder. But for right now, we are only interested in the pitch. All right. So let's look at the model. And now we're going to go back over to AutoCAD. So this is a finished product here, and I'm going to move this aside so that I can start drawing, right? And you're probably wondering why I have two drawings there. Well, this first one is the path, and then this second one shows the path with a square section. So I've just put that here. This is a square section. What do I mean by that? I mean that if you were to cut this in half, this would be the square right here. And this will be the shape that goes all the way from the bottom to the top. So it actually has a thickness. So I changed the path into an actual shape. All right. And this is what it will look like. The red dashed lines represent the hidden lines in there. So let's get this going. So let's move this out of the way. So what's the strategy? The first thing, I'm going to draw this. So that's the first thing that's going to be drawn. Then after that has been drawn, I'm going to divide this into 12, right? So that is 12 divisions. So that'd be 12 divisions there. Divide that into 12, that's the second thing. And this is the first thing. And then after I've done that, I'm then going to draw this rectangle here. That's the third thing I'm going to draw. Okay, after drawing all three of those things, I'm then going to divide the rectangle also into 12. So I'm going to pull out here so, and then I'm going to put divide into 12. Div 12, all right? So that's four things I'm going to do so far. Once I've gotten to this stage, then I'll discuss the other things that I'll be proceeding to do next. Let me just clear the drawing and let's start here. So let me always keep my reference here on the right-hand side, and let's start. So the first thing is C for circle, and I'm going to create my circle. They say my circle is diameter 70, so that means it's radius 35. 35 there. For those of you that might want to see things better, it's right there. So the diameter is here. So that means that's 35 radius. Okay. Now, next thing, I'm going to divide this, div, divide, select the object, type 12. My 12 divisions are there, and then I'm going to connect them. Cool. Let me just put them into a construction layer. Good. So all my divisions are in. Now what's the next thing? I'm going to offset this distance, which they've told me, 45, between the center here and where the base of this next joint is going to start. So just project these lines out. So give myself some space, and then offset, that's 45 distance, going up, and then from there, offset that 75. Okay, cool. So just draw lines to connect. I'm going to fill it so that I have the shape there. All right. Again, put everything in construction there, right there at this stage. Now, what am I going to do? I need to divide this surface now. Again, this surface will be divided into 12. All right. So I come back here and put into AutoCAD, select the line, div is the command. Touch there, 12, enter. Cool. Now I need to copy this line up 12 times. So CO for copy, grab that line. No, I don't think I was on the end point. Grab the line, move it up, touch it there, hit array, and 11, and should have put in 12. Okay. So I got what I wanted. So I got my 12 divisions already set up. Now, what am I going to do? I'm going to project lines from down here up. Right? So you can grab this line and copy it. Okay. So I have my grid. I have my lines from my circle. They're projected up and I have my 75 divided into 12, and all my divisions are in. Now, what am I going to do? Let's clear over here and let's come back here now. What's the next thing? I need to start here at P. So I'm going to locate where P is going to be, which is going to be here. And P is also down here on my plan. So that's my P. After I've gotten that, what's the path that P is going to go? So I'm going to choose this path. So P is going to go there 1, 2, 3, 4, and so forth. So let's go 1, 2, 3, 4. I'm going up. Yeah, got it all in. Good now. So I would just draw that. Right, and that will be it. That will be my path. So now let's plot this. So the first thing, let me bring up a point and place it there. And I'm going to be carrying my point with me. So what I'm going to do is I'm going to distinguish this point and place it into my text layer so that I always know the points that I really need to plot. So I'm going to copy this and I'm going to move up the line. 1, 2, 3. That shares that point, so I don't need to put 1 there. So that's 1. So let's start if this were 12. 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. Let me now use SPL spline to put this in. Select, and I just keep drawing this curve. Connecting all the points. When I get to the end, hit enter. And that's my path in. So far I have just entered the path. All right. Now, basically, the question is done at this stage. Except for we need to show the hidden line. So, of course, if you really look at this logically, this part here, so you're going to see. But when it gets here, anything that's behind here is going to be hidden. So that means you need to show it in dashed lines, right? And then when it gets back here, you're then going to see it full. So the solid white, or what I should do is put it in red. The parts that are in red, yeah, you're going to see that full. You're always going to see these parts based on the elevation that we are looking. We're going to be looking at it this way. So we're going to see the path as it gets to here, right? And then we're going to see it as it picks back up from here to there. So let me just let's reference that, and that goes to here. All right. The other bits that are behind, you're not going to see, which are these bits here. You're not going to see that. You're not going to see that, which is here. All right. Okay. So how do I fix this now? Yeah. So I can break this path. Instead of exploding it, I can break. So I hit BR, enter, and I'm going to clip the path here and then break it and pull it back to there. Enter again to reactivate the same command. Just zoom in and grab it, touch anywhere here, and pull back the break line to there. So what does this mean then? I can actually pull this to there. No, I don't want to. Just leave it there. I'll leave it there like that. And I'm going to go and match drop. Or I can put this, let me see, if I put it into hidden. Yeah, you don't have to match drop anything. Just put it into the hidden layer. So that's it. They're done. So I have answered this part of the question. Show hidden lines, right? Now, how have I shown the hidden lines? These are the hidden lines there. So I'm convinced that that is done. Construct a right-hand helix on the circumference. So let's go again. A right-hand helix on the circumference of the cylinder. So this is going around the circumference of the cylinder, right? Right, so that is done. Starting point at P. Okay, well, I need to locate my P. I need to actually show P. That P is there, and then P is going to end right here. So this is the starting point, and then this will be the finishing point right here. So I need to label that. I need to label this drawing, draw the given views. So I need to label this drawing. So plan is going to be here. Yep. And elevation is going to be here. All right. And then you need to also locate where P is. So a little bit of cleaning up or just tidying, making things clear. Now, how am I going to put in P? M text, MT. Where my text, okay. And I just come here, click, and I open a box and I just capital P. All right. I generally don't like my points, my lettering to touch the point. I just move it off slightly like that. No, I think it's a bit too far. So just bring it here. Yeah, great. Now I'm going to copy this to the top. That's P there. And I'm going to copy it down at the bottom. That's also P. Right? Next thing I'm going to do is I'm going to label these joints. So I'm going to label plan down here, and I'm going to label elevation. MTX. And do that and call that elevation. Just justify and putting it in the middle so it looks neat. Grab this, copy it down here, and we call that plan, right? Cool. Next thing I'm going to do, I'm going to number these points so that everyone be able to see. So I'm going to just okay. So far, so good. Now let's compare this answer to the model. Let's bring back up my 3D model. Let me turn on my, oh, sorry, take off the perspective and look at it this way. We can see here the height is 75, but over here, we are assuming the height is 75. So what it tells me, I need to add my dimensions, right? DIM. Here. That's dimension there. And we can look at this now, and we can clearly compare what we see here. So let me go for the annotation. And let's start. We can see here, this is where we start. This is where we start. You can see here, this is the path that we take all the way to the top here. We can see the path here all the way to the top. What else we can see? 75. But we can't see the actual, we can't see the plan. We can't see that because based on the elevation, we're not going to see the plan. But I'm going to rotate the model. Now, we can have a look at, that's how the plan looks. Right? That's the plan. So everything looks correct. Everything is corresponding. Now, the question is finished at this moment here. But some people might be interested in placing a square section onto the path and tracing this so that you can have a three-dimensional look as to how it will look like or what it would look like. Let's do that. So I'm going to take a moment to just show you how I arrived at this, and y'all can choose if you want to do it. But generally, at this stage, the question is finished. Oh, you need to label. Yeah. Let me label what I've done so that I can get all my marks I've drawn. And now I need to label. So what is this here? And this would be path of helix construction. All right, now is a good time I should place everything into its proper layer. Okay, I think everything is all in the layer it's supposed to be in. Good. Oops. Good. So, okay, so seeing that we have just finished the question now, I'm going to attempt to put this square section onto the question and show you what the path will look like, what the shape will look like when it's finished. All right. First, before I do that, I want to redraw this path. So I'm going to pull this out here and redraw the path. I want to redraw the path because I don't want it to be broken. So I'm just going to redraw this path and make it whole. SPL is the command that I'm using. We go. Then when I get to the end, I hit enter. So that's my path there. Oh dear. I don't think, let me just pull this back to there. Yep, that looks good. That looks good. Now I'm going to now put my square onto here. So let's go here with the square, offset up. Let's go 5. No, 5 is a bit too much. Let's go 4. 4 and draw a line. Cool. Then offset 4 across there. REC for rectangle. Good, let me make it just right there. So that's my square. I'm gonna hatch that, and now I'm going to carry this all the way up. So I'm going to move here, and I'm going to copy, and I'm going to bring this to right here. But look what happens. When it gets to this side, it stops, and it goes around the curve, right? Okay. So we can even look at this and understand the faces that we're going to be able to see and the faces that are going to be hidden. Anyway, let us proceed now. So let me go copy. And this is where it gets interesting when I give it a thickness now. So that's the thickness there. And let us see so far, because these are the three lines that I'll be seeing, 1, 2, 3, when I'm looking at it from this face, right? I'm going to be seeing these three lines. I'm not going to be seeing this line in here that's going to be hidden. So I'm not worried about that right now. Personally, not worried about it. Just dealing with what I can see to understand this. So this is going to be right here. And you look, this goes into here. And then at this moment, this line disappears and it goes behind here. So that means this becomes a hidden line. All right. So I'm going to break this line right there. So I will know that immediately at this moment goes into a hidden line. And it goes all the way hidden until it comes right back to here. So just going to put a break there again on it right there. Slip. So this is an individual line now. It's no longer one line right there. So I can match drop this to the hidden there. Yeah. So that's hidden. All right. It's a bit confusing, but we'll get through it. Now, this piece here doesn't go outside. Or we could just leave that there for now. Let's see, what's the next thing that I need to put in? I need to put in this piece now that we weren't seeing before. So this goes in, and let's see. Now at this stage, oh, this is hidden right to about here, right? So I'm going to break this line around here, pinch it off there, yeah, and all this is hidden. So we're going to put that into the hidden layer, match drop it to there. That's hidden. Then when it gets here, now we're able to see it, and we're able to see this as the inside face, and this goes all the way up to here. That's hidden is revealed, and this that was shown gets hidden, right? This gets hidden all the way. So I need to break this now, break, because we're not going to see this bit here. You know what? Let me break it here. Yeah, break it right there. So this is hidden all under here. We're not going to see as it goes up to the top. That's hidden. So let's match drop that. Yep, that's our hidden line. And that's our hidden path. Now, is this finished? No, it's not finished. All right, let me just move this up here. All right, so let's walk myself through this now. So if I were, that would be the face. I'll be seeing this would be the top. Yep, that would be the top. That would be the top, still the top, still the top, still the top. It can't change from the top. That's the top. There, 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 and then there. So we have highlighted the top, right? But I'm going to put the top into a different hatch color. Let's go with, yeah, that one. Just do it that way. All right. So that's the top. All right. This reminds me then I'm not going to see this. This is going to be not going to see that. Let me match drop this. It's all one material. All right. So what parts aren't we going to see now? A line needs to come down here. Or like a tangent line. Yeah. Got it? Cool. All right. So now let me hatch the sides. So this is going to be a side face. That's going to be a side face. And in there, side, side, and then that will be a side. So that would be, let's call that the inner side, right? And yeah, we could leave it in gray. And this also would be, yeah, let me hatch the size in just gray. So it's not to confuse anyone. Oops, nope, I didn't want that hatch. I just wanted in here. Oops, problems there. Skip and come back later. Oops, nope, problems again. I know what to do. I'm going to take off the layers that I'm not using. Oh, no. Let's do this. Remove the construction lines. And that should be it. Now we're getting to see this thing in its full 3 dimension. Should have done that ever since, you know? Oh no, wow. Oh, right. This is not this is not going to work because I have a break in these things. Right. Now we cooking with gas, as the old people would say. And if you are joining in not from Barbados, that's the Barbados saying. I don't know if it's worldwide, but cooking with gas, I've certainly heard it in Barbados. Right. Never heard it outside of Barbados, but you know, probably it might have originated somewhere else. Anyway, I'm straying. Let's get back focus. This is the path. This is the square section. So we got the path here. You know what? I should probably put an arrow here and do that. Yeah. Why not? Make this look good for YouTube. Path of Helix construction. Cool. Whoa, this is a bit large. Wait. Okay. 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 And I'll just copy this over. So I've turned off all the layers so that we can just get a look at it before I wrap up this video and conclude. And this would be the helix of a square base. Yeah, square base section going up and around all the way to the top. All right. So let's turn back on everything and recap. If you wanted to find out what would have gotten you your marks, it would have been just this. That's all you had to do to get your marks, and that. And then the question is finished there. So let's recap again now. Let's look back here. Look at the model. This is the model. Again, I use this model to explain what a pitch is and to show a three-dimensional look of what I have done in AutoCAD. Okay, so I came into AutoCAD here and I answered this question. Right, the question asks, Figure 6 shows the plan and an elevation of a cylinder with a point P on it. Draw the given views, construct a right-hand helix on the circumference of the cylinder, starting at point P. Show hidden lines. So I've done that. This is what it looks like here. I hope that this gave you all a better understanding of how to construct a helix, and that you would be able to know the parts of the helix so that you can confidently get this done. Again, I always encourage people to practice practice till you get things right. You might not get it right the first time, but keep doing things over and over, and eventually it will come like second nature to you, to your brain and to your fingers. Like, share, and subscribe to the channel. I am out.